Hi, I'm Jaehyeok Han from South Korea. I'm going to talk about data acquisition from web-based service without password, and I used credential attack. Before presentation, I'd like to appreciate this opportunity to show our study. Following contents I prepared. So, firstly, motivation for the digital forensic investigation. Traditionally, the data was acquired from the digital device, since all the data should have stored in internal storage of the digital device. But with growing interest of the privacy, we are commonly using the online service. So we used to upload and save our files on the cloud. It means that client-centric aspect is now stored on server side. Mostly, we use both an ID and a password to log in for service. But in this study, for the bypassing this process, we used we used credential attacks such as cloning attack or cookie reply attack. As a contribution of this study, the first we tested 14 popular services, and this result will have to acquire more user data as much as possible. Secondly, we discussed their security measures and features. For the credential attack, we wrote a attack model as follows. As a first step, we collect available credentials from given data image and then tested security measures. We found some weak point in each service after several trial and error. In the end, we did bypass and acquire data as we intended. We tested all these services. They are categorized by cloud storage, messenger, and so on. As an experimental result, we acquired a lot of files uploaded by user and her history. As a example, there are documents, pictures, chat logs, etc., etc. In this slide about discussion, frankly speaking, I need to talk a lot, but I'm just going to mention the first listed thing. Multi-factor authentication. This method is granted access to a service only after successfully presenting other factors. But in our result, even if MFA had said our attack was worked, so we could access to the target user's data. Others also support for security. However, there was no problem to get data on server side. Conclusion, we thought collecting only from digital device was one of limitation of traditional investigation. So we tried to gather more and more cloud native aspect, and we did it. But as you know, the world is changing, thus it is necessary to identify online services, security measures, and features continuously. Since I have only 5 minutes for presentation, so I present it briefly. Moreover, because this is a paper, I couldn't show enough material hours. But if you have any questions, please contact my email. Thank you for listening.
Hello everyone, my name is Aikaterini Kanta and I'm a PhD student with University College Dublin and the European Commission's Joint Research Centre. I'm here today at DFRWS APAC 2021 to present a comprehensive statistical analysis on the crackability of real-world passwords. The average number of passwords a user needs to remember was shown to be 27 in one study, although a whopping 191 in another one. And this is because we use passwords for everything. We use them when we go to the bank, we use them when we log into our social media. They can be of different types. They can be numerical, they can be phrases, and they can be patterns. And lately, we've seen that for critical websites, multi-factor authentication has been used more and more. But still, the single password remains the most popular method of authentication. This is why we decided to look into leaked passwords, and more specifically the Have I Been Pwned list, which contains passwords from 3.9 billion real-world accounts stemming from various data breaches. For this list, we have statistics on the length, makeup, and strength of these passwords, such as how long it will take to crack them and what the built-in components of these passwords are. Our paper, which contains this analysis, is currently under review. One part of the analysis of the paper is the fragment analysis, which we perform using a tool called ODIN, which can segment the passwords into fragments and then analyze them and classify them according to their semantic meaning with the help of WordNet. The types of fragments that can be found in a password are letter fragments, numbers, and special fragments. For example, the password Manchester.2019 is split into Manchester, which is classified as a city, dot, which is classified as a special character, and 2019, which is classified as a year. You can also see on the slide the number of fragments per category and the total number of fragments, which is about 1.5 billion. It's worthy to mention that the original Have I Been Pwned list contained about 500 million passwords, which means that the number of fragments is about 3 times as much. You can also see the 10 most popular fragments per category, and there are some entries that are not very surprising, such as keyboard works, sequences of numbers, single digits, and single symbols. Here you can see the most common fragment categories. We can see that the 3 most popular categories contain numbers, with the category common number describing numbers that are either sequences of numbers or numbers that are meaningful to us, such as 314, which is the number for pi. We can also see that other categories containing names, like masculine name and feminine name, are very popular, and also categories with cities, animals, computers, food, colors, emotions are also very popular. We can also see the most frequent fragment combinations, where again a combination of common numbers is the most popular one. Another combination that is very interesting is that names, like masculine and feminine names, are followed by a number, a digit, or a year. The results of this analysis show that even in a dataset as large and as diverse as Have I Been Pwned, there is indeed context to be found in passwords. Demographic factors, like whether someone is male or female, whether they're English or non-English speaking, what their age is, and their profession, play an important role in password selection. For example, one study of Chinese-speaking users showed that about 50% of them use only numbers in their password. Users also tend to include familiar models in their passwords, personal information such as male and female names, birth dates, city names, and pet names. This is why one of the most popular categories was a male or female name followed by a number. Users also use their own interests like animals, food, and emotions when they create their passwords. But is this useful to a digital investigator? If you want to gain access to the device of a suspect, you can look into their digital life, like the information from their local devices, their online presence, and their previous passwords. All of that information can then be used to create a personalized dictionary of keywords, and then in conjunction with mangling rules, create a smarter dictionary list that is tailored to the suspect. This means that during the password cracking process, password candidates that are likely to be the password will be checked first, thus expediting the process. Thank you for watching this short talk, and please don't hesitate to reach out to us with any questions.
Hello everyone, I'm Daisuke Sumita from National Police Agency, Japan. Today, I'm going to be presenting on identifying crypto API usages in Android apps using a static analysis framework. This is a joint research with Professor Kanta Matsuura from Institute of Industrial Science, the University of Tokyo. So let me begin with the motivation of our work. As you know, recent mobile apps often encrypt their local storage data. Such encryption prevents forensic investigators from quick data analysis. Fortunately, there are many helpful existing works fight against mobile apps data encryption. They rebuild the encryption schemes, thus we can decrypt the data. However, most of such works rely on manual analysis. For handling mobile apps encryption, application analysis is key to the solution because mobile apps often derive encryption keys and parameters using locally stored data. Then just revealing decryption behavior in apps could decrypt encrypted data. So in this work, we identify standard crypto API usages in Android apps via automatic application analysis. Next, I'd like to explain our problem definition. It's common to use Cipher class API, which standard Java crypto API for data encryption in Android apps. For using Cipher class API, some typical parameters are needed. Then we defined our problem as an identification of parameter derivation used for Cipher API calls with Cipher decrypt mode. This could be extended for other script APIs. Then, this slide shows analysis approach overview for our problem. We divide the analysis into 3 steps. First, find Cipher API calls with decrypt mode. Next, analyze typical crypto API usages for each Cipher call. Finally, analyze source APIs for parameters derivation used for each crypto API call. I'd like to explain source of parameter derivation for crypto API calls a little more. We made these 5 categories for the sources. They indicate that encrypted data could be decrypted with locally stored data or not. We built analysis implementation using an existing static analysis framework, Android, leveraging its taint analysis capability. And we conduct analysis tests for 139 real-world apps collected from F-Droid. We successfully discover and identify 178 crypto API calls and 212 parameter sources. Finally, let me briefly summarize our work. We select and categorize typical Android APIs, which is used for the parameters of Android standard crypto APIs. We develop a static analysis tool for Android apps, which identifies the usage of crypto APIs. We conduct experimental tests on real-world Android apps. As a result, we can discover and identify crypto API calls and used parameters. In the future, we want to expand support for more parameters and improve accuracy of analysis. Thank you for listening.